we are going to discuss here is the motion of the center of mass. When the particles moves, the center of mass also move. अब just imagine करिए, ये दो particles है, just imagine ये दो particles है, अगर मैं ये दोनों को रेस्ट पे रखता हूँ, center of mass यहाँ बीच में है बेटा, ये भी तो रेस्ट पे रहेगा, लेकिन जब मैं इन दोनों particles को move कराऊंगा, तो center of mass क्या पीछे छूट गया? नहीं, इट इज नॉट पॉसिबल, राइट? तो ये सेंटर ऑफ मास जैसे जैसा हम दो पार्टिकल्स को मूव करते जाएंगे या एन नंबर ऑफ पार्टिकल्स को मूव करेंगे, तो सेंटर ऑफ मास भी उनके साथ आगे बढ़ने वाला है. So this concept we are going to study under the concept motion of the center of mass. So under this concept of motion of center of mass, we are going to study about the velocity of the center of mass, acceleration of the center of mass, momentum of the center of mass. Different concepts are there. We are going to study one by one. So main heading what we need to give here is the motion of the center of mass. So let us go with this motion of the center of mass. Under that, first one, velocity of center of mass. Velocity of center of mass. So how to move, how to deal this concept, that is the velocity of center of mass, let us see. देखिए, just now we have seen the position vector of the center of mass, that is RCM is equals to M1 R1 plus M2 R2 plus M3 R3 by M1 plus M2 plus M3. This we have already seen. This the concept what we have just seen. M1 plus M2 plus M3. Can I say this is total mass of the system? So total mass of the system means M1 plus M2 plus M3. So I don't want to write every time M1 plus M2 plus M3. So in short, I take the total mass as M, where M is M1 plus M2 plus M3. So this I'm writing here it as RCM, that is equal to M1 R1 plus M2 R2 by, third particle is also there, M3 R3 by, I'm taking here it as M. What is this M? Capital M is the total mass, M1 plus M2 plus M3. Just you cross multiply, इसको हम cross multiply करेंगे बेटा. क्या मिलता है हमको cross multiply करने से? M1 R1 M2 R2 M3 R3. So this is the concept what we have seen. यहाँ तक तो हम already पढ़ चुके हैं. अब we need to have the velocity of the center of mass. And you know what is the velocity? Velocity is rate of change of position, rate of change of displacement. That is the velocity. So for that, what I do here is I consider this as equation 1 and I differentiate this equation. इसको हम differentiate करेंगे to get the concept of velocity or the velocity terms आने के लिए. तो हम लिखेंगे यहाँ पे what I am writing here is differentiating 1 with respect to time. चलिए differentiate करेंगे. Mass is constant, leave as it is. If you differentiate this, d by dt of RCM, that is equal to, try to understand, mass is constant, उसको हम बाहर ले रहे हैं, RCM as it is. Now this is mass is again constant M1. Here what I have to take it here, M1 d by dt of R1 plus M2 d by dt of R2 plus M3 d by dt of R3. Now this is M as it is. It is what? Something like rate of change of position. So can I say that is the displacement? यहाँ पे देख लीजिए, this is the displacement. And displacement किसका displacement? This is for the change in the position of the center of mass. So therefore, whatever I am getting, this is the velocity of the center of mass. Velocity of the center of mass. This is M1. This is dr by dt. So this we can write it as v1. And one more thing, this is a vector. So velocity is also a vector. We keep one bar on that also. Okay. Plus M2 v2 bar for this. This is R2. So therefore v2. And here we can write M3. This is what? v3. If you students, if you analyze this इसको अगर हम थोड़ा सा एनालाइज करेंगे, mass into velocity we are getting, is it not the momentum? Product of mass and velocity, this is the momentum. This is the momentum of the first particle, momentum of the second particle, momentum of the third particle is the momentum of the center of mass. That means momentum of the center of mass is sum of the momentums of all the masses. This is the concept what we are getting, new concept. इसको हम जो है ना थोड़ा सा मैं ब्लॉक में लिखता हूं so that you will be stressing on this concept also. इसको हम skip नहीं कर सकते हैं बेटा, because the problems can be framed on the momentum concept also. That is momentum only. This is momentum. This is the momentum of the center of mass, momentum of the first particle, momentum of the second particle, momentum of the third particle. Now let us see. Our aim is to find the velocity. This is our aim, right? तो हम यहाँ पे velocity में निकालते हैं. देखिए कैसा निकालेंगे हम. VCM is equals to m1 v1 m2 v2 plus m3 v3 by, if I take this m in the denominator, this will be m. But you know, students, already we have considered this m as m1 plus m2 plus m3. देखिए बेटा, what is this m? ये m क्या था? m1 plus m2 plus m3 था. So therefore I have taken it as m. अब हम m को replace करते हैं उसी term से, that is m1 plus m2 plus m3. So it is very simple if you understand. If I take the particles like I am having the position of the center of mass as m1 x1 plus m2 x2 for two particles I am speaking. अगर हम दो पार्टिकल्स लेते हैं बेटा, वहां पे अगर मैं पोजीशन पूछता हूं तो इट इज व्हाट m1 x1 plus m2 x2 by m1 plus m2 we take, right? अब उसी तरह से अगर दो पार्टिकल्स है मूविंग विद द वेलोसिटीज v1 एंड v2 है, तो हम यहाँ पे क्या फॉर्मूला फ्रेम करेंगे? vcm is equals to m1 v1 plus m2 v2 by m1 plus m2. फोर पार्टिकल्स है तो आप अपने हिसाब से फ्रेम करेंगे. इट्स वेरी सिंपल इफ यू अंडरस्टैंड. वन मोर थिंग, the very important thing here what I would like to discuss, if suppose the two particles are moving in the same direction, I repeat once again, दो particles है, दोनों particles एक ही direction में जा रहे हैं बेटा, तो उस situation में आप use करेंगे m1 v1 plus m2 v2 by m1 plus m2. I'll give you an example here. Just इसको हम example मान के चलेंगे. This is m1 moving with the velocity v1, m2 moving with the velocity v2. So what is the concept we are going to use? VCM is equals to m1 v1 m2 v2 by m1 plus m2. Try to understand, both the particles are moving in the same direction. अब हो सकता है कि भाई one particle is moving, m1 is moving with the velocity v1 in this direction and m2 is moving in this direction. This is m2 and this is v2. So you can see the directions are opposite. So under that situation, you cannot use this formula. So in that situation, we have to use m1 v1 because the direction is reverse. So we have to use it as m1 v1 minus m2 v2 by m1 plus m2. So you have to be very careful whether the particles are moving in the same direction or they are moving in the opposite direction. I hope you have understood the complete concept of velocity of center of mass. Students, we move to a question which is based on the velocity of the center of mass. The question on the board is here. Two particles of mass 1 kg and 2 kg are moving along the same line with speeds 2 meter per second and 4 meter per second respectively. Calculate the speed of the center of mass of the system if both the particles are moving in the same direction. So here the masses are given, velocities are given, and we need to calculate the velocity of the center of mass, but the condition here is the two particles are moving in the same direction. So I think you got the concept what we need to use here. So velocity of the center of mass is equals to m1 v1 plus m2 v2 by m1 plus m2. So m1, it is 1 kg. As per the question, 1 kg and 2 kg masses are given. 1 kg and this is velocity is how much here? 2. Plus, why I'm taking plus? Both are moving in the same direction. M2 is 2 kg. This is 2. And that is velocity is how much? 4. I hope you are getting 1 kg and 2 kg are the masses. 2 meter per second and 4 meter per second are the velocities. So this is 1 kg is moving with 2 meters per second. 2 kg is moving with 4 meters per second, divided by m1 plus m2, that is 1 plus 2. So it is 2 plus 8 by 3, that is 10 by 3 meters per second. Students, we move to the next problem based on the same concept, velocity of the center of mass, but it is not the direct question. It's a standard question. Let us move with this. So the next standard question on the board here, you can see two particles A and B initially at rest move towards each other under a mutual force of attraction. Initially, they are at rest. They are at rest, and because of the mutual force of attraction, mutual force means that is an internal force. Because of their internal force only, they are going to move. And at the instant when the velocity of A is v, जब उस A की velocity v है and the velocity of B is 2v, the velocity of the center of mass कितना है, that we need to calculate. पहले तो दोनों particles rest पे है बेटा, एंड बिकॉज ऑफ द म्यूचुअल फोर्स, दोनों के इंटरनल फोर्स की तरफ से ये दोनों आगे बढ़ना शुरू हो गए. जब ये दोनों आगे बढ़ रहे हैं तो ए की वेलोसिटी है 2v और बी की वेलोसिटी है v. नहीं, ए की वेलोसिटी है v एज पर द क्वेश्चन. ए की वेलोसिटी v है और बी की वेलोसिटी 2v है. तो velocity of the center of mass कितना होगा, that we need to calculate. So mutual force of attraction means what I can say, the equal forces, they are going to move with the equal forces. So what I apply the same concept here. Here you can see m1 is equals to m2. That means both the forces on the particles are same. m1 f1 is equals to f2. But you know, students, what is the force? For as per the Newton's second law of motion, F is equals to ma. That concept I am applying here. m1 a1 is equals to m2 a2. m1 a1 is equals to m2 a2. But what is acceleration? Acceleration is change in velocity by time. Rate of change of velocity is acceleration. You can see the initial velocity of both the particles 0. Initial velocities of both the particles are 0. So what is the final velocities? For A it is v and for B it is 2v. So I am speaking about only A. So change in velocity कितना होगा? Acceleration is change in velocity by time. तो कितना change in velocity हुआ बेटा? पहले 0 था, अब बन गया है v. तो change in velocity is v minus 0. That is v only. So therefore I take in place of a1 velocity v by t. Rate of change of velocity is acceleration. Now second, दूसरे के लिए देखिए m2. What is this a2? A2 is the acceleration of the second body, that is b. How much is the velocity? Initially rest पे है 0. अब कितना हो गया बेटा? 2v हो गया. तो change in velocity is how much? 2v minus 0. 2v minus 0 हो गया. अब जब हम 2v minus 0 करते हैं, it is 2v only, right? तो this is 2v by time कितना? I'll take it as t. Now just say this v and v get cancelled, t get cancelled. m1 is equal to, I say it is what? m1 is equals to 2m2. This is the relation what I am getting for masses. Masses का ये relation है. Now students, if I take the concept of velocities of the center of mass, so velocity of the center of mass, it is m1 v1 minus m2 v2 by m1 plus m2. You may get a doubt why we are taking this minus. The reason here is both are moving in the opposite direction. मैं आपको clearly बता चुका हूं था बेटा कि भाई because of their internal forces they are started moving, right? जब ये move हो रहे हैं अपनी तरफ, तो both are moving in the opposite direction. That is not mentioned in the question. It is understandable. So m1 v1 minus m2 v2 by m1 plus m2. Now let us see what we are getting. m1, what is m1? m1 we can write it as 2m2. And what is v1? As per the question, v1 is v only. Minus m2. Let us take m2 only. What is v2? It is 2v by m1 plus m2. Now students, if I just simplify this, what I am getting? 2m2v minus, this is also 2m2v. 2m2v by m1 plus m2. So this and this get cancelled. Exact terms I am getting 0. 0 by something is a 0. So the velocity of the center of mass at the instant when the velocity v for A and velocity 2v for B, it is center of mass is 0. This is the concept what I have shown you, or I can say this is the proof what I have given you for this complete question. But remember one thing, the position of the center of mass and the motion of the center of mass does not depends on internal forces. इंटरनल फोर्स पे ना तो पोजीशन डिपेंड होता है बेटा, ना तो उसका मोशन दैट इज वेलोसिटी उस पर डिपेंड होती है बिकॉज ऑफ द इंटरनल फोर्स. अब मैं जो आपको, अब आइए मैं फिर शुरुआत के क्वेश्चन में की शुरुआत में जाता हूं. I was saying that these two are moving towards each other because of mutual force of attraction, and that mutual force of attraction is an internal force. So internal force do not affect the position of the center of mass and velocity of the center of mass. तो अब आइए क्वेश्चन पर. इनिशियली सेंटर ऑफ मास क्या था, दोनों बॉडीज रेस्ट पे थे, तो सेंटर ऑफ मास भी रेस्ट पे था. अब ये दोनों मूव हो रहे हैं बिकॉज ऑफ द इंटरनल फोर्स, तो पोजीशन ऑफ द सेंटर ऑफ मास एंड द वेलोसिटी ऑफ द सेंटर ऑफ मास विल नॉट गेट चेंज, वो भी रेस्ट पे ही रहेगा. एंड दैट इज द कॉन्सेप्ट व्हाट वी हैव with what I can say the characteristics of the center of mass, the problem and its solution I have shown you on the board. Students, we move to the next concept under the motion of the center of mass, that is acceleration of the center of mass now. Now, acceleration of the center of mass. So we have seen already what is the velocity of the center of mass. So I take with that only, I'll move with this. So that is the velocity of the center of mass. I'll take for only two particles, that is m1 v1 plus m2 v2 by m1 plus m2. I'm taking only for two particles, velocities of the center of mass. Now together the complete mass, I'm considering it as capital M. So the formula gets modified, that is m1 v1 m2 v2 by this is m. Now just cross multiply it. What I am getting here, m vcm is equals to m1 v1 plus m2 v2. Suppose this is equation 1. Our heading, our concept of discussion is acceleration of the center of mass. But here the expression what I have taken for velocity of the center of mass. To convert the acceleration, to get to the acceleration, we have to differentiate this equation with respect to time. The reason here is the rate of change of velocity is acceleration. So here let us differentiate this, that is differentiating one with respect to time. With respect to time. So if I differentiate this, we are getting m dvcm by dt plus is equal to, not plus, is equals to m1 dv1 by dt plus m2 dv2 by dt. Now this is the rate of change of velocity of the center of mass. So this will become acceleration of the center of mass. This is the acceleration of the first particle, acceleration of the second particle. So let us move with that. So this we can write m acm is equals to, this is m1 a1 plus m2 a2. Now what is acm now? It is acceleration of the center of mass. It is m1 a1 plus m2 a2 by this is m. I'm taking this in the denominator. Now what is m? What we considered m? M we have considered as the sum of the masses of all the particles. So therefore here I'll take it as, just modify it, m1 a1 plus m2 a2 by m1 plus m2. So this is the concept what we need to move with the acceleration of the center of mass. And if you observe, students, we are not getting anything or different. If you know the position of the center of mass as m1 x1 plus m2 x2 by m1 plus m2, the velocity we have seen as m1 v1 plus m2 v2 by m1 plus m2, the same concept we are getting for acceleration also, m1 a1 plus m2 a2 by m1 plus m2. So here what we have studied today completely, you need not to remember that, just you have to go through the concept of position acceleration and velocity, what we have discussed. I hope you have understood the complete concepts of today's class. Thank you.